So today's first part is really jumping into this idea of what projectile motion is. And projectile motion sounds really fancy, but it happens around us all the time. So anytime you throw a ball, anytime you jump off of a diving board, projectile motion is happening. And what happens is that basically the trajectory that you follow is a quadratic equation. It's a parabola. So here's just a silly example of something that's flying through the air, right? We're going to say, if you look at your notes, this is the path of a rocket as it flies. And you're going to see on my next slide, you have this equation, right? So here's the equation of how that rocket is flying through the air. But the trajectory of it is this parabola. It starts out on the ground, it flies, it gets higher and higher into the air, and then eventually what comes up must come down, and so it comes all the way back down to earth, right? So the question is, can we really understand what these different components are and the different attributes of it? So let's start with that first question. If we just want to ask, well, how long was the rocket in the air? So if you think about that, well, the rocket left the ground at 0 seconds, flew through the air, of course, and then hit the ground right here. So that's telling me that it was in the air for a total of 8 seconds. So on that first line, that's what we're going with. We had 8 seconds that we were in the air from start to finish. But then the next thing is, well, how high did it get? What was that greatest height? That's going to be a really common question that we ask throughout these next two lessons. So obviously you can see that the highest it got was that point right there. Now we don't know exactly what number it is, right? Just by looking at a graph, we can kind of estimate. So just so you realize, that's 200 and that's 250. So I'm not sure if we're going up by tens or not here, but it looks like that's 210, 220, 230, 240, 250, right? So I'm going to say maybe 260, right? Ish. Right now we're just looking at the graph, so 260-ish is about my highest point, right? So on this next line, that's what we're looking at, is about 260 feet. This keeps popping out. 260 feet. Come on, disappear for me. It won't stay away. But anyway, we're looking at 260 feet is our highest, our greatest height. Number 3 says, well, about how high is the rocket after just 1 second? So if we go back to our picture, our time is across the bottom. Our time is across the bottom. So 1 second is right here. So what we want to do is want to kind of like figure out, well, where is it at about 1 second? So I'm looking maybe right about there, maybe 100 feet. That's a pretty good estimate, I'd say. So 100 feet high after 1 second. And if we keep moving and I say, well, what about 2 seconds? Right? Well, same idea. If we go 2 seconds out, we get a different color, and we go straight up. Well, where is it at 2 seconds? We've actually got a point there. I'm going to say that's about 180, right? That's about 180. So 2 seconds is 180 feet high. And then the question at that point is it going up or down? And that's why the graph is so important, because you can definitely tell that at this stage of flight, the rocket is definitely increasing in height, right? We're still going up. So we're definitely on our way up into the sky at that stage and not going back down. Let's skip forward a couple seconds down to 6. So 6 seconds is this same guy. And what's interesting about that is it's the same height as it was before. And that's simply because when the rocket goes up, it's got to come back down. It's not going all the way into outer space. So it is going to be that about 180 feet again. All right, 180. But this time, instead of going up, our rocket is coming back down, right? So the whole point of this is to really make sure we kind of understand what's going on. And the next question says, well, when do you think it's traveling faster? At the very beginning, 0 to 1 second, or later on, 3 to 4 seconds? So this is a good one. I'm going to make this disappear here so that we can kind of visualize. From 0 to 1, that's basically that section of the graph. But from 3 to 4 is this section of the graph, right? So I would really challenge you to think about, well, where do I think the rocket is moving faster? And so what's actually happening here is that the rocket is moving especially fast at the beginning. When you get your first maybe ignition of the rocket, that's when we're really, really traveling fast. So it's definitely from 0 to 1 seconds. And then right here, you're kind of running out of gas, right? You're running out of fuel. And the truth is, there is a very, very brief moment when we get to the vertex. We've talked about that point already. When we get to the vertex of the parabola, your speed is actually 0 miles per hour. When you get to that exact tip top point, for a very brief moment, you're just completely still in the sky, right? The rocket is completely still. So to answer these up, let's finish it. We're definitely faster from 0 to 1, right? We were definitely going faster from 0 to 1 second. And then the question number 7 finally says, all right, we've been looking at a graph this whole time, but let's use the equation. Let's start to use the equation to find out the exact value at 2 seconds. And so we may have forgotten about that equation by now, right? But I highlighted it right there in pink. That equation is actually going to give us the exact values. So negative 16 t squared plus 128 t. So all we have to do is, since it's 2 seconds, we're going to plug into negative 16 something squared plus 128 times something. And that something is our time. So it was 2 seconds. T stands for time. So that's 2 seconds that we know we're trying to figure out that the exact height instead of just approximately. What did we approximate? I think we approximated 180, right? I think we were off there. I think it should have been 190 maybe. Yeah, I was way off. It should have been 190, shouldn't it? Anyway, Crouch is off his game. So let's plug it in and see what it actually should have been. If we plugged in that 2, we always do exponents first. So negative 16 doesn't change, but the 2 squared becomes a 4. And then plus, we can go ahead and multiply 128 times 2. That's going to give me 256. Now we multiply those together, right? So 4 times negative 16 gives me I think it's negative 64. So now negative 64 plus 256, if we add those together, we get, I think it's around 192 feet. So even that 190 was still just a tiny bit off. So the whole point here, guys, is to really get you familiar with the different kind of vocabulary and visualization of what's actually happening on a parabola, right? This is where our rocket starts. We're looking at different exact times on the rocket, what are our exact heights. This is the very tippy top of the rocket where it maxes out its height. And then remember, this was down here was when that rocket actually came back and landed on the ground and actually went back to Earth. So that's our introduction to projectile motion. And in the next video, we're going to get into the actual math behind solving some of these equations. And today, we're going to start out with solving without a calculator. So we'll jump into the next lesson.